Warahmatullahi wabarakatuh, and hi. So in this video we will learn about alkanes. So basically we can find alkane in LPG. LPG is a liquefied petroleum gas, okay, where we use in our daily life. Alright, so in this video first we will learn about the structure of alkanes and then followed by nomenclature of alkanes. Okay, so alkanes come from family of hydrocarbons. Okay, hydrocarbon is a compound that contain mostly carbon and hydrogen. So here is alkane. Alkane is aliphatic hydrocarbon. That is hydrocarbon compound containing carbon and hydrogen joined together in a straight chain, branch or non-aromatic rings. So alkanes is a saturated hydrocarbon that contains only single bond. Other than alkanes, we also have cycloalkanes. Alright, so for structure of alkane, we have open chain alkanes that have general formula CnH2n plus 2. Meanwhile, for cycloalkane, the general formula is CnH2n. For example, if we have propane, the molecular formula is C3H8. Meanwhile, for cyclopropane, the general formula is C3H6. Okay, and then we will go to the naming the structure of alkanes. Okay, so we will name the structure of alkanes according to IUPAC. Okay, that is International Union of Pure and Applied Chemistry. So first, before we go to the more complex alkane, here is the IUPAC name of alkanes. Okay, so for alkane, they have A and E or N suffix. For example, if we have 3 carbon member, so the name is propane. Okay, we can see from methane, ethane, propane, butane, pentane, we have suffix A and E. Okay, and then followed by the other members of alkane. Okay, the other series of alkane, we have hexane, heptane, octane, nonane, and decane. Okay, so this name, okay, you need to learn by heart. Okay, so this is for more complex structure of alkanes. That is branch alkane. So how we name it? First, we will choose the longest continuous chain. Okay, so we have 2 structure here. So how we can choose the longest chain? So for this structure, okay, it just simply choose the straight one. However, in order to choose the longest chain, we need to identify which way that will produce continuous chain. So for here, we have this chain is the longest continuous chains that consists of 7 carbons. So this is the first step. Okay, so now we have 7 carbon as the longest continuous chain. Okay, and then we can identify the branch. Here is the branch. Okay, next. Okay, so if 2 different chains of equal length are present, choose the one which has more substituent attached to the main chain. For example, you can start to find the longest continuous chain from here also. However, if you find the longest continuous chain from here, you will only find 3 substituent group. Okay, 1, 2, 3. Okay, if we identify the longest continuous chain from here, we can get 4 substituent group. So this is higher. This have higher priority. Okay, and then number the longest carbon chain so that the substituent receive the lowest possible number. So this is about how we start numbering the carbon. So if we start number the carbon from carbon here, okay, so our substituent will number 3, 4, 5 and 6. So this is a large number compared to the structure. If we start number 1 from here, so the first methyl group is on carbon number 2, ethyl group number 3, methyl group number 4 and the other methyl group number 5. So we can see between these 2 structure, okay, this structure has smaller number of substituent. Okay, so what is substituent? Substituent is a substituent alkyl group. Okay, and then alkyl group are named by replacing the A and E suffix of alkane with YL. For example, if we have methane, so when it comes as a substituent, it becomes methyl. For example, if we have propane, when it becomes substituent, we will name it as propane. So this is the other series of the substituent. Okay, you can go through this one. Okay, and then for the step 4, by using rule number 3, locate the position of the substituent and name the substituent. So we have locate our substituent. So for example, this is number 2, this is number 3, this is number 4 and this is number 5. Okay, If two or more identical substituents are present, use prefix such as di, tri, and tetra. So we have 3 methyl group. That's why we name it as 3-methyl. That indicate we have 3 methyl group. Okay. And then in order to write the name, okay, so then the name of substituent and its position must be placed in front of the parent name. It comes first and then followed by the parent name. So arrange substituent in alphabetical order. For example, if we have ethyl, methyl. Okay, so when we follow the alphabetical order, ethyl will come first as it starts from E. Okay, and then prefix di, tri, sec, ter are ignored except iso and neo. Okay, and the numbers are later are separated by hyphens. This is hyphens. And if we have numbers and numbers, we will separate it by comma. Okay, so let's see the next slide. So in order to name it, okay, we must follow the rules. Okay, so this is the correct name, 3-ethyl. Okay, because ethyl is placed on the carbon number 3 and the letter E comes first, and then 2, 4, 5. Okay, so 3 hyphen, okay, ethyl because we want to separate number and letters, and then hyphen because we separate letter and numbers. Okay, 2, 4, 5. We have comma because we want to separate number and number, because methyl group are attached on carbon number 2, carbon number 4, and carbon number 5. So it is 2, 4, 5, 3-methyl. Okay, and then we have no other substituent. Okay, so we go to the parent name, that is heptane. So the name for our compound is 3-ethyl 2,4,5 3-methyl heptane. So this is how we name branch alkanes. Okay, so this is a practice for you to try. And then other than branch alkane, we also have cyclic alkane. Okay, so for cyclic alkane, we will add prefix cyclo and the suffix "-n" to the parent name. For example, if we have C3H6, okay, the name of the alkane will become cyclopropane. Okay, so cyclo is our prefix and "-n" is our suffix. So this is the name of monocyclic compound. Okay, and then for our cyclic alkane, if we have substituent, okay, if we have substituent and the substituent is only one, so we don't put number to the substituent as we consider it attached to the carbon number 1. Okay, so for example, this compound, the name is methyl cyclohexane, and for this compound, the name is chlorocyclopropane. However, if we have two different substituents, we will number the ring to assign the lower number to the substituent alphabetically. So for example, if we have two substituents here, okay, this one we name ethyl and this one we name methyl. So the correct way, we put number 1, okay, alphabetically. So ethyl will attach to the carbon number 1 and methyl will attach to the carbon number 3. So we name it 1-ethyl 3-methyl cyclohexane. And then how about if we have more than 2 substituents? Okay, so for ring with more than 1 substituent, begin numbering at 1 substituent and continue in the direction that gives the next substituent lowest number possible. This is the example if we have more than 2 substituents. Okay, so for here, if we start numbering our carbon, start from here, so we will get the lowest number for substituents. So we have 1 here, 2 and 4. So 1 plus 2 plus 4, the total is 7, right? And then if we start numbering from methyl here, okay, and we continue number it, so methyl carbon number 1, ethyl carbon number 3, methyl carbon number 6. So if we add the number of the substituent, okay, we will get 10. Okay, and then how about we try to number it alphabetically? Okay, so this is 1, this is 3, and this is 4. So if we add 4 plus 3 plus 1, it is 8. So in order to find the lowest substituent number, okay, this is the structure. Okay, because each of the substituent get small number. Okay, and then if we have the other condition, so for example, naming compound containing both ring and long chain of a carbon atom. So how we number it? So in order to choose the parent of the compound, we will identify which one that has more carbon. For example, we have cycloalkane and we have straight chain alkane. Okay, so here for the carbon chain here, we only have 4 carbon. Meanwhile, for our cyclohexane, we have 6 carbon. So the substituent, okay, is cyclohexane. And this 4 carbon chain will become the substituent. We will name it butyl. Okay, and then if we have the other condition, we have cyclic alkane and the straight chain alkane. So for the cyclic alkane, we have 6 carbon, and for the cyclic alkane, we have 4 carbon. So we can see that the 6 carbon, okay, the straight chain here has more carbon. So this 6 carbon chain will become a parent. So the parent name is hexane, and the cycloalkane will become substituent. So the name is cyclobutyl. So we will name it as 1-cyclobutyl hexane. Okay, so this is the practice. Okay, you can try both practice 1 and practice 2 for naming of alkane. Okay, so if you have any inquiries, don't hesitate to ask your lecturer. Thank you.